You've got a formula chart there up at the top, and then we can refer to that the whole time. It's got all the things on there. Maybe specifically look at the quadratic formula that almost nobody remembered on our little activity. That's what I was talking about with the quadratic formula. But our first section of notes to take, or our review to go over, is all about linear functions. So two lines are said to be parallel if they have the same slope. Maybe highlight that word parallel, that's important. We know this, they go the same direction, so they have the same slope. Two lines are said to be perpendicular if they have opposite reciprocal slopes. What does it mean for things to be opposite reciprocal? Correct, opposite sign, flip fraction. And when we're writing an equation of a line, you always want to start from point slope form. And the reason it's called point slope form is because you will use a coordinate point, x1 and y1, and a slope, m, to write that equation. We always start there. So of course, the first three problems we're not going to spend all that much time on because you can kind of see. We found the distance and midpoint between those two coordinate points, plugging into the formulas that are at the top of the page. I'm going to assume we can kind of follow that work down. We fill in a formula, we multiply, we do all that stuff. I do want to zoom in on one part of the distance formula. How did I go from here to here? What did I do? How did it go from being square root of 52 to 2 square root of 13? The little tree thing, right? So whenever you have final answers, we're going to assume that I'm always asking for them to be in simplest form. It may not explicitly say it, but we're going to assume we always simplify. That's just polite math technique. So if we break down 52, it's 2 times 26, and 26 is 2 times 13. When you learned this, hopefully, maybe not, you would have taken all of the pairs of numbers and written them outside of the radical, outside of the square root, and all of the singleton numbers, and kept them inside the square root. So that's where those numbers came from. Does that ring a bell now? If this was not a square root, if it was a cube root, I wouldn't circle pairs of numbers. What would I look for? Threes, trios of numbers. Okay, cool. That's using the distance formula and then midpoint. Again, not really all that worried about that. You can read a formula, plug some stuff in. What we are going to spend some time going back over, and we did really well with this last time, is finding the slope of a line. Last time, almost everybody made it through the levels needing to find slope. It's a formula you use, the difference in the y's over the difference in the x's, so the y's are on top, x's are on bottoms. We kind of see example 2. We all did that one really well last time. In example 3, this is kind of where we lost some people last class. When you're writing an equation, anytime you write an equation, you're going to have to write it in point slope form. To write it in point slope form, we need a slope and a point. This problem only gave me 2 coordinate points. So I used those 2 coordinate points to find my slope, the same way we just did in example number 2. y2 minus y1 over x2 minus x1. Is that okay? Did we follow that part? After that, once you have a coordinate point, which was given to us, and a slope, which we found, we can plug the coordinate point and the slope into point slope form, which is right here. There's my slope. Here's my coordinate point of -3, 6. Now this might be a good point to write down point slope. That's what we used right there. We always start equations from point slope form. And if it just says write an equation, stop there, you're done. That's technically an equation. This one does ask to go all the way to general form, or standard form is another name for it. So what did I do to go from the second line of this equation, or I guess from point slope to the next line? What did I do? Say it again? I did. I distributed. So if we draw those arrows there so you can see, that's what happens next. Anytime you have a number in front of parentheses, you distribute. So we would multiply -4/3 times x and -4 times, what? -4/3 times 3, and we would get what we got here. Now, how did I go from here to here? What did I do? I added 6 to both sides because we're trying to isolate the y. So to show my intermediate steps, this is what I did. +6 + 6. The 6's are going to cancel out. Negative 4 plus 6 is positive 2. Does anyone recognize what kind of equation that is? Great. What's the name of that one, though? Slope-intercept form. It is our normal linear equation, but it's called slope-intercept form because it tells us the slope and the y-intercept. So far we've seen point-slope. We've seen slope-intercept. Too bad I asked you to write it in general form because we have to keep going. General form, if we look up at the top of your paper, is all of the x's and y's on one side and a constant on the other, with a side note that a and b cannot be fractions and a must be positive. So if one of the numbers a and b is a fraction, we have to get rid of it somehow. So keep that in mind for what I do next. I ran out of room, so I had to come up here. I'm so sorry. But if you look up there, how did I go from this equation to this equation? I moved the x over. I added 4/3 x to both sides. So if you want to show that step, I did plus 4/3 x and plus 4/3 x. Now it's sort of in standard form because the x's and y's are both on the left-hand side, but x's and y's, the coefficients of those, a and b, cannot be fractions. So what did I do to go from this step to this step? I multiply by something. Almost. Times 3. Why would I multiply by 3? Yeah, if we want that denominator to go away, if you want to, instead of dividing by 3, we're going to multiply by 3. But when you do this scalar of 3, you have to actually do it to the entire equation, which feels weird because you're distributing across an equal sign. Yes, I know that. You're totally allowed to do it when you're writing in standard form. The 3's are going to cancel here, so now 4 is just by itself. 3 times y is 3y, and 3 times 2 is 6. That's general form. Does that sort of make sense? Cool. If we're going to move on to the inside, I've also done most of the problems on this page, but what we're going to do is I'm just going to give you time to look through them with the people you're sitting with and figure out what happened. When we annotated the front side, we kind of wrote down some stuff of what's happening. You added in arrows, maybe added some stuff. I want you to do the same thing to examples 4 and 5. See if you can figure out how I went from start to finish for those two problems. I'll give you some time. I actually started these problems over here. Both of them actually started right here. Did we notice this part? Okay, make sure you talk about what I did here, since that's the real start of this problem. So for number 4, sorry if I'm cutting off your thinking, it asks you to write an equation in general form that passes through this coordinate point -2, 2 and is parallel to the line 2x minus 3y equal to 7. Why did I do all of this business over here? Yeah, I converted it from standard form to slope-intercept. Standard form doesn't tell me anything about the slope just from looking at it. But slope-intercept form totally does. This number is the slope of that line. So if I wanted to use something that's parallel to that, I would use the exact same slope. We know this symbol means parallel? Yes? From geometry? It's been a minute, I know, I'm sure. But the parallel slope is 2/3, which means now that I have a slope and I have a point, I can take that point and that slope and fill in point-slope form, just like we did before. So here's my coordinate point, -2, 2, and my slope. What's the next step? What's that called? Starts with a D. Distribution. Ooh, where'd the 4/3 come from? How did I get that? Multiplying. When you multiply fractions times numbers, it's just the top of the fraction times the number. Keep the denominator the same. Top times top, bottom times bottom. So I've got 4/3. Okay, what happened next? Add 2. Yeah, but where'd that 10/3 come from? How did that happen? What you mean? Because yes, but tell me more.
Added 2 to the fraction.
I did. How do I do that in my head, though? They have to have a common denominator. There we go. Right now, 2 has a denominator of 1. I want it to have a denominator of 3. So what do I have to multiply the top and bottom by to make it have that common denominator? 3. Well, isn't 6 divided by 3 still 2? I changed nothing about the problem except that now I can combine those fractions. 4 plus 6 is 10, so we have 10/3. Okay? From here to here, what happened? Move the 2/3 x to the other side. And what is the number that I multiplied everything by? -3. Good eye on that one. Why would I multiply by -3 and not just 3? So the coefficient of x is not negative. So we'd multiply this by -3, this one by -3, and this one by -3 to get it in standard form. Number 5 is pretty much exactly the same except for this section right here. What was different about this part? It asks for what kind? Perpendicular. So I don't use the exact same slope that I get for that line. I use its what? Opposite reciprocal. So I changed the sign and I flipped the fraction. So -1/4, its opposite reciprocal is 4. So the slope that I'm going to use is 4. Did we follow everything pretty much after that? Yeah, so again, this is point slope, where we use the coordinate point 3, -5 that they gave you. We distributed. We subtracted 5. We moved the 4x over. And I multiplied at the end by what? -1. Okay. There's our linear equations section. Do we feel kind of okay manipulating equations around, moving things from side to side? It's all inverse operations, all things we've been doing for a while. I just got to clean it up a little bit. But then we get away from linear equations, we can go to quadratics. Now there are a bunch of methods for solving quadratics. The 4 that we're kind of going to touch on, we're actually not going to use the quadratic formula today, but we're going to write it down because we should still know it, is factoring. Factoring is the one where you end up with the 2 parentheses. That's factoring. We're going to use the guess and check method in this class. The square root method is the one where you end up with a square root, or sorry, something squared equal to some number. And to solve it, you take the square roots of both sides. The thing I want us to remember about the square root method is that when you take a square root, what do you have to add in front of it? Plus and minus. Completing the square is the one you're not going to be comfortable with, and that's okay. We're going to get more comfortable with it. Completing the square is a long process, but since we're just writing things down, it would be helpful for us to remember when looking at all these words. Write down b divided by 2 squared. I will teach you how to do that because I know you don't know how to do it. You might have heard the words before, done it once, and moved on. And then, of course, you have our quadratic formula, which is x equal to -b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now that you see it, do you remember learning about that? Yeah. So these first 2 that we're going to do, we'll do one together and then you'll try number 2. Obviously, this is kind of how it's going to work. But we're going to use the guess and check method. I'm going to teach it as if you've never heard it before, just in case you were always using X puzzles or a box factoring. That's okay, use it as long as you need to, but factoring becomes like a really small step in much larger problems that we'll do in this class. It should be fast, which means the guess and check is the best way. When using the guess and check method, we still need to identify A, B, and C, just so we know the parts of this polynomial that we're factoring, the quadratic. When we set up our parentheses to factor, eventually we're solving, but we're going to solve by factoring. You keep that 5, the A value, in the first parentheses only. And you put the X in the other parentheses. You're like setting yourself up to be done almost already. Then, and I'm going to show more work than I really will. I'm going to erase it so you can see what it should look like start to finish. But what we are doing is we're going to take that C value, the green value, -3, and we're going to list out all of the things that multiply to -3, which are 1 and 3. Not a very big list. I know it's negative and I didn't put any negative signs. I'll deal with it in a minute. Some combination of 1 and 3 here in these 2 spots will solve my problem. If I try 1 and then I try 3 like this, and I go and I do outside multiplication and inside multiplication, I would get 15x and 1x. Is there any way I can combine 15 and 1 to get negative 2? No. So that's not going to be the version that I want. So that was my guess and my check. We're like, that didn't work. We try again. So we flip them around. What if we try 3 and 1? This is 5x. This is 3x. Is there a way to combine 5 and 3 to make negative 2? Yeah, if this is a negative 5x, which means there's a minus sign here and a plus sign there. Now, of course, I don't really want to have to see all of this, so all of the arrow drawing, all of this business should be done in our head. We should go from quadratic to factor. That's the goal. It doesn't have to happen overnight. So if you still need to write that stuff down, show the arrows, do all the things, that's fine, do it. We're still learning. Now, of course, it says solve, not factor, so we need to do something else with these two things to be able to solve it. What we're going to use is called the zero product property. You don't really need to know that, but that's why this works. And basically, because any number times 0 is 0, you can take the first factor and set it equal to 0, and you can take the second factor and set it equal to 0 and solve for x. Now these, I hope we're able to do without showing any work. We should be able to look at the second one and say, x is equal to 1, no problem. Add 1 to both sides, you have x equal to 1. We should be able to look at that first one and say that x is automatically equal to negative 3 over 5. Solving a two-step equation should happen in our head at this point. We subtract 3 to the other side, we divide by 5 on both sides. If you need to show the intermediate steps right now, that's fine, please do so. But we should be able to go pretty quick from zero product property to solutions. Opposite sign, constant divided by coefficient. That's all it is. Questions, comments, concerns? Can we try one on our own? Or with your teammates? Okay, you've got number 2. Try it by yourself. Ask your teammates for help. Ask me for help if you need it. Okay. If I were doing this one, and I saw across the board pretty much everybody did this, so awesome. We do have to move that 12 to the left-hand side of the equation, because when we're solving quadratics, we need to set them always equal to 0 almost no matter what. Quadratic inequalities or equations, we have to have it equal or less than equal to 0. Now when I do that, I can set up my factors to have a 3x in the first parentheses and an x in the second. I'm looking for factors of 12 that will end up adding to negative 5. I missed one. 1 times 12, 2 times 6, 3 times 4 are all of the factors of 12, which means we have potentially 6 things we have to check because they both go both directions. If I do 1 and 12, this is 36, this is 1. Is that at all going to be close to making negative 5? Yeah, no. Okay, so if we switch those even just around, this is 3 and 12. Still doesn't make 5, so probably not those. If we try 2 and 6, that would be 18 and 2. So that's a no-go. Doesn't make negative 5. We could try 6 and 3. Wow, not 3, 2. It's embarrassing. 6 and 6 doesn't make negative 5. It would really only make 0 or 12. So we try 3 and 4. That would be 12 and 3. Still not negative 5. But we could try, as a last resort, 4 and 3. That would be 9x and 4x. Is there a way to make negative 5 out of that? Yeah, negative 9. So that means this is negative and this one's positive. Now, of course, now that's just factored. What are the solutions? To find the solutions, we take each of the parentheses and we set them equal to 0. And we can do a two-step equation to solve. This is x equal to negative 4/3, and this is x equal to 3. Those are my two solutions. I'll leave you time to write. I know a bunch of people are writing it down now. Don't panic. In fact, this polynomial, this quadratic, I guess I should start calling it by its proper name, really can only be solved by completing the square or the quadratic equation. But we're going to do completing the square because nobody's comfortable doing it, and we have to do uncomfortable things sometimes. So the process for completing the square is going to be probably new to everybody, because I know in Algebra 2 when I taught it, I skipped it. So you've probably never seen it, and that's okay because we need it in this class, and we can learn it in this class. To complete the square, what you're going to do first is you're going to take the constant term, and you're going to move it to the other side. So that this would turn into x squared plus 2x plus a blank, I'm going to put a box because I think it's fun, equal to negative 5 plus another blank. Because what we do to one side, we have to do to the other. So I have to leave blanks on both sides for the number that I'm going to add to this problem. To figure out what number I'm going to add to this problem, what we're going to do is we're going to take that little formula I told you to write down next to the words completing the square, b divided by 2 squared, and we're going to use it to find out what goes in that little box. Where do you think the b comes from? In a quadratic, what is normally b? In linear equations, yes, your y-intercept, but in quadratics, isn't this usually a, b, and c? So we're going to use that b term, and we're going to plug it into this formula. So we'd have 2 divided by 2 squared, because that's b right there. 2 divided by 2 is 1, and 1 squared is 1. I'm showing all of that work on purpose. I highly recommend showing from start to finish on this kind of step. So the number that I get here is the number I'm going to put in the boxes. That's what I want to add to both sides, because what it does is it makes the left-hand side what's called a perfect square trinomial. A perfect square trinomial automatically factors to x plus the number inside the square. I'll highlight it so you can see it. This number that was inside the square part is what it factors to, which is why I want you to show that step. And this is going to be equal to negative 4. Now I'm going to pause for a second because I got a good amount of questions about literally this step earlier. The first one you're probably going to ask is, where did the negative 4 come from? Great question, right here. What is negative 5 plus 1? Negative 4. Second question I got earlier is, how did this happen? Great question. So this trinomial, if we were to factor it, don't write this down, just watch. If we were to factor this, I'd have an x in both of them. What are the things that multiply to 1? 1 and 1, right? Doesn't 1 plus 1 add to 2? So this is x plus 1 squared. That's what I wrote down here. So what this does is I get to skip all this business, and I don't have to do this factoring. I know that this automatically factors to x plus whatever number is in this little parentheses. Okay, I'm gonna erase all this because we don't need to see it. Are there any other questions before I keep going? Okay, our goal still though is to get x by itself. So we need to get x out of that little squared thing. How do you undo something squared? Square root it. So if I go to square root both sides, what do I have to add to this side? Plus minus. Okay, and I never leave myself enough room for plus minuses, so I'm just going to sneak it in there. Okay, the square root and the square are going to cancel each other out, so we just have the x plus 1. And then I need to take the square root of negative 4. What is the square root of negative 4? Not almost, no. The square root of 4 is 2. What's the square root of negative 4? Oh, it's actually a letter. No. So the square root of any negative number is I, your imaginary number. So this square root of negative 4 is actually equal to 2i. Oh my gosh, we forgot imaginary numbers exist, didn't we? Anytime you take the square root of a number and it's negative, you add an I. The square root of negative 1 is I. Okay, we're so close because remember, to solve an equation, no matter what kind of equation it is, x has to be by itself. How do I get x by itself? Subtract 1 to both sides. Now, 1 and 2i are not like terms. One of them is real, one of them is imaginary. So you just do this. Oh my gosh, I forgot my plus minuses the whole time. So my two solutions are -1 plus 2i and -1 minus 2i. Whoa. What are our questions? None yet? How about this? We try one. You can try example 4. I'll spoil it for you. You have to complete the square on this one as well. See if you can take what we just did and apply it to a new problem. And if you can't, there's where your questions are. And then you ask me questions. How about that? Let's try it. Great place to be. Okay. So if we were doing this one, I would have tried to factor first, and it wouldn't have worked factoring. I like factoring first because it's usually fastest. So I start to complete the square. First thing I do is move the 7 to the other side so I can create a perfect square factor. So I have a space here, and I have -7 and a space here. I need to know what number goes in there. I find that by doing b divided by 2 squared, which is 6 divided by 2 squared, which is 3 squared, which is 9. Now, I don't show a lot of intermediate steps unless they're important, just me as a mathematician. And I'm showing all of these because the 9 is important. It goes in the box. The 3 is important because, the 3 is important because it goes in the parentheses. So this becomes x plus 3, all of that squared, equal to whatever -7 plus 9 is, which is 2. Yes? Okay. From here, I think we mostly have it from here, which is solving by square roots. We would square root both sides. The square and the square root cancel each other out. So we would just have x plus 3 equal to plus or minus square root of 2. Radical 2 does not simplify. So we leave it as radical 2. If it did simplify, we'd simplify it. If it was negative, we'd take an I out, but it doesn't change at all. All we do is move the real or the rational part of this over. This would be -3 plus or minus radical 2. Are you stretching or are you a question? Oh, okay. That's fine. You can stretch. I just was like waiting for a question. How do we feel about this? Any other questions now that we've seen 2 of them? All right. Next topic we're going to go over is quadratic inequalities. Now, this may be completely different from how you've solved inequalities in the past, specifically quadratic ones. It'll touch on some things I know you know, but probably different than how you've ever done it. The way that we're going to solve these quadratic inequalities is with critical numbers and sign charts, which is what you can kind of see is happening here on your paper. So we're going to annotate this first one, kind of like we did on the front page, so you can see what's happening, and then we'll do one together because we're not going to be ready to do one on our own. First things first, what happened from what was printed on the paper to my first line of handwriting? What did I do? Move the 6, because I need it to say equals 0, greater than 0, or less than 0. So we need it to be equal or something to 0. That's important. It's where it always starts. Now, the first line to the second line really doesn't look like I did anything different, but this section here is when I find my critical numbers. Or critical values, we'll call them critical numbers. The way I do that is like by pretending that this inequality is an equation. So literally from the stuff that I put in the box, minus the number line, that's exactly what we were just doing. I factored, I solved, and then I put it on a number line. Why on this number line? First of all, notice that it's not perfectly, like you don't have to give me tick marks or whatever, just make sure the numbers are labeled. Notice though that I used open circles here. Why would I use open circles on my number line? Because it's not equal to. At the very beginning of this problem, the symbol that was used was less than. Less than. So I know that I'm going to have an open circle when it's less than. When it has an equal to underneath it, what will that change to? Closed circle. So if we want to write that down for ourselves, our open circles go with the less than or greater than sign. They're also parentheses in interval notation. Less than or equal to and greater than or equal to are a closed in sign. And instead of parentheses, what do I use for interval notation? The little brackets. Okay, cool. Just some things for us to remember as we do this problem. I like putting cute little clouds around stuff, so I'm going to do that. Once I've done essentially just solving a quadratic, I have now on this number line created 3 intervals. You have interval 1, you have interval 2, and you have interval 3. I'll color code these for us. We have interval 1, we have interval 2, and we have interval 3. I need to test my quadratic in each of these intervals to figure out what is happening with that quadratic. Is it above the x-axis or below the x-axis? Positive greater than 0, negative less than 0. So I do that with a sign chart. What I'm going to do is I'm going to take each of these intervals and I'm going to fake plug in. You can't see me because I'm standing behind most of you, air quotes, plug in a number. I'm plugging in a number. I don't care the number I get out. I care about the sign that I get out. So what I did in this first interval is I plugged in -5. Why in the world would I plug in -5 in that interval number 1? Less than -2. As long as it is less than -2, you can use it. I like picking easy numbers to use like 5, 10, 0, 1. -5 is less than 2, so I plugged in, air quotes, -5 into this equation. Put a little star next to that, double star. If I plug in my head -5 here, 2 times -5 minus 3 is a negative number. -5 plus 2 is a negative number, which is why I wrote 2 negatives right here. What is a negative times a negative? Positive. So that section is positive. What number did I choose in that second interval to use? 0, because 0 is between -2 and 1.5. Way easy to use the number 0. So we plug in 0. If we plug 0 in for x, it's 0 minus 3. That's a negative number. 0 plus 2 is a positive number. Negative times positive is negative. Do we see how the sign chart is working? I usually lose people here, so it's okay if you say no. The third interval, I'm using number 5. Again, anything that's bigger than 1.5 you can use. So it's like I plugged in -5 right here and -5 right here. Wow, not -5. 5. Embarrassing. Okay. 2 times 5 is 10. 10 minus 3 is a positive number. 7. 5 plus 2 is 7, another positive number. So that section is positive times positive, which is a positive. Now, all of that to say, I know now that in that first interval, from -infinity to 2, my graph is above the x-axis because it says positive. In the second interval, it's below the x-axis. In the third interval, it's above the x-axis. So how do you answer the actual question here? What is the actual question here? Amazing. Glad you asked. If we look back up at the top, it wants us to solve when this graph is less than 6 or less than 0, which means we want the section where it is less than 0. That middle section is where it's less than 0, which is why I colored in on my number line the section in the middle, and I answered from -2 to 3/2. I use parentheses because they're open circles. This kind of problem is a doozy, so before we even try another one, let's look through it one more time, make sure we addressed any questions we might have. Why are you not zooming? There we go. Look from top to bottom. If there's a part, it's probably going to be the sign chart. Is there a part we don't understand? These stump people every year, don't worry. Okay, if we're doing this one, first of all, it already says 0, so we're good. So we're going to treat it like it's an equation and just change that greater than or equal to sign to an equal sign. But we're going to keep in mind that for this one, we want things that are above the x-axis. Okay, we want things that are above or positive this time. Now, I've skipped saying this pretty much every time we factored just because I haven't needed it yet. But the very first thing we always truly need to check when we're factoring is for a GCF. Do those two terms have a GCF? Yeah, what are they both divisible by? and x. So if we take out a 5 and an x, that's my first factor, I'd be left with x squared minus 4. It's like dividing out a 5 and dividing out an x. Does anybody recognize this? What is this? It's subtracting two things. Are they both squares? Yeah, this is the difference of two squares. So we have a whole little pattern for that. The difference of two squares pattern is that it's the first thing minus the second thing, the first thing plus the second thing. And if you're like, what? That's a 4. Why'd you write down 2? Isn't 4 the exact same as 2 squared? That's the difference of two squares. That's just a quick factoring pattern that allows us to go from step 1 to step 2 very quickly. You still technically could guess and check that because the center term is 0. But at this point, we have it fully factored. We should be able to just find my critical numbers very quickly. We find them by setting each individual factor equal to 0 and solving. So what's my first critical number? 5 times what is 0? 0. Okay, there's one critical number. What's the next critical number? 2. And what's the next one? Negative 2. I'll slow down. On our number line from negative infinity to infinity, we have 3 critical numbers where the equation is equal to 0, meaning crossing the x-axis. We have critical numbers at negative 2, 0, and at 2. Please make sure they're in the right order on the number line, like an actual number order, not just in the order you found them. Happens. Do I put opened or closed circles on these? Closed, because the symbol we started with has an equal to underneath it. So how many intervals was created here? We have interval 1, 2, 3, and 4. So we're going to have to test 4 different values to see if the graph is a plus or a minus. Now, this whole time, we're going to be plugging them into this part of the equation. And put like 18 stars over here. This is the one we're plugging it into with all the parentheses. What number would y'all like to use for the first interval? Sure, we'll use negative 10. I heard that first. Negative 5 is fine. Negative 3 is fine. Negative 10, aggressively more negative than negative 2. It works. If I plug negative 10 in here, what's 5 times a negative 10? Negative 50. I care about the negative. If I plug a negative 10 into x here, is it positive or negative? Negative. If I plug a negative 10 right here, positive or negative? Negative. Okay, so I have negative times negative times negative. What is that? Negative. All right, so the first part, the first interval, is below the x-axis. Can you guys try the other 3 intervals? Interval 2, 3, and 4. Pick a number in that interval, plug it in to use the sign chart, and tell me if it's plus or minus. I'm going to start writing my steps on the board, so if you're super lost, you can look. Otherwise, don't look till you're done so you can check your work. But if we go back to the actual question here, what are we trying to even answer? What's the original question? It's asking for where the graph is Above or below? Above, so positive. So we want these two sections here, this one and this one, those are the two intervals that I would color in on my number line. So we want to color in the numbers from -2 to 0. That one's good. And from 2 all the way to infinity. That's a number line representation of my answer. Any x value in that colored in section is going to work in this inequality. But of course, you don't always answer with a visual. You do answer in interval notation, which means the graph or the numbers that we can use start at -2 and go to 0. And then we have a small break, so we use the symbol U for union. We pick back up at 2 and go all the way to infinity. Now question, I was using all of these brackets and then all of a sudden I put a parentheses at the end. Why? Yeah, we never actually touch infinity. Infinity is a concept. No one's actually counted to infinity yet because it's infinity. So the bracket means that we're touching that number. We are at that number. That number is where we're standing. We'll never be actually standing at infinity because we just like be chasing it for forever. So that one always gets a parentheses. Oh my goodness, that was a lot. Are there any questions before we just leave that quadratic inequalities for a second and do some fun stuff with I? Yes? This one? So when we plug in the number -1 here, if we plug -1 in here, 5 times -1, that's a negative number, right? And then if we plug in -1 here, -1 minus 2 makes it more negative. It would be -3. But if we plug -1 in here, that's a bigger number, and it's positive. So -1 plus 2 is actually +1. That's where this positive comes from.
So like, how does the signs interact to make positive?
Gotcha. Anytime there's two negatives make a positive. So negative times negative is positive, positive times positive is positive. Good question. On to our last topic. We got it. We all forgot about this earlier, so I'm really glad this is on here. Imaginary numbers. They're going to come back. They're always out there just waiting for you. There's 2 things about imaginary numbers we need to remember. Well, I guess 3 things total. Number 1 is that anytime you take the square root of a negative number, it's equal to I. That's what we forgot earlier. That's okay. I'm telling you now. But the further, or therefore, thing that we know from that is that anytime that we have I squared, it's going to be equal to -1. And we get that because if you square both sides of what I've highlighted in red, I squared is I squared, and square root of -1 squared, those 2 things cancel out, you're left with -1. We will need that fact. The next thing is that what we have what's called a complex conjugate. The complex conjugate is the plus and minus version of every complex number. So when we have a complex number, we have a real number A, and we have plus some imaginary number B. Real plus imaginary. That's a complex number. The complex conjugate is the same real and the same imaginary part, just change the sign of the imaginary part. So if you have A plus BI, its complex conjugate is A minus BI. We will need that for division, really only. Imaginary numbers are very easy to use because in essence, they work like combining like terms. So if we are adding and subtracting complex numbers, all we have to do is add the real parts and add the imaginary parts together. In this problem here, we have 2 real numbers, 2 real parts of 3 and -4, and 2 imaginary parts of 4i and -2i. If we're adding those 2 complex numbers together, you just basically CLT, which means combine like terms. 3 plus -4 is -1. 4i minus 2i is positive 2i. And that's it. It's basically combining like terms. You're combining real with real, imaginary with imaginary. Which also means that subtracting them is just like how we subtracted expressions since forever. I like to actually do the distribution first because I lose negative signs like nobody's business. So I'm going to distribute and then I'm going to combine like terms. So I'd have negative 6 minus 5i plus 3 minus 2i. And now it's just like the first problem. You put the reals with the reals, the imaginaries with the imaginaries. This would be negative 3 minus 7i. Are we okay? That one, whew, you're like, finally, something easy. Cool. We're going to continue with something a little bit more simpler than what we did on the other page. We're going to multiply complex numbers together. This is going to be really simple if you know how to FOIL. What does FOIL stand for? First, outer, inner, last. Multiplying complex numbers is just a FOIL problem, just double distribution. We multiply the first numbers. I got 3. 1 times 3 is 3. Check. We multiply the outside numbers. 1 times negative 2i is negative 2i. We multiply the inside numbers. We get 9i. And then we multiply the last numbers. And we get negative 6i squared. Do we follow that step? Okay, all of a sudden a lot happens in very little time. The inside part, really simple. Do we notice that these are like terms? So we just combine them like we've always done the middle terms. Negative 2i plus 9i is 7i. But what the heck happened to the 6? Eventually I did add it to the 3, but how did I go from here to here? Ooh, I times negative 1 because at the top of this paper we have a fact that says I squared is equal to what? Negative 1. So really, I can cross this I squared out and put in its place negative 1. What is negative 6 times negative 1? Positive 6. That's where that positive 6 came from. Then to finish this on up, I have 3 plus 6, which are both like terms. That creates 9, and I'm done. Make sense? Okay, I want you to try the next one, but I'm not going to just, I confused my first class today with this one because I forgot that this little trick was there. If you look at example number 2, what's happening on that second term? It's squared, which means what? There's 2 of them. Yay, please don't do this. My heart dies a little bit every time somebody does that. You can't distribute a square into a parentheses with plus or minuses in it. You can only do that if it's a monomial or a single term. So instead, we write it like this. So we have that first parentheses, but we have 2 of the second parentheses. Looks like this one's way more complicated. It's really not all that more complicated than one we just did. I want you guys to try it first, but please multiply these 2 before you multiply the last 2. I promise you it will make the problem very easy. So you're going to FOIL those first 2 and remember what I squared is equal to, and then get me my final answer. You'll see what happens after that. Something cool happens. One of the things I'm seeing a lot of is not knowing what to do with that third factor. So, okay, I got you. If we were to do the first factor, we would multiply and we'd FOIL it. We'd get 4 and then negative 6i and then positive 6i and then negative 9i squared. Do we do that? What I didn't see a lot of is dropping this down every single time. Don't let it float away. Proper math follows from line to line. So yes, you have to rewrite it every time, but it needs to follow every time you go because now you don't lose it and you know what to do with it later. When we do this, the 6 i's are going to cancel because one's positive, one's negative. And this I squared is going to become negative 1. So really, that first little bit turns into 4 plus 9, then multiply by 2 minus 3i. What's 4 plus 9? 13. We have 13 times 2 minus 3i, which is so nice because that is not another FOIL problem. That's a single distribution problem instead of double, which just means I would end up with 26 minus 39i. Is that better? Okay.